Hello everyone. In this lecture, we are going to see about mixers in RF transceivers. Mixers. It is a crucial component that plays a significant role in the modulation and demodulation of radio signals. It is responsible for two processes. One is frequency translation, another one is frequency mixing. Frequency translation, it is translating signals between different frequency bands. Then mixing, to combine two or more input signals to produce an output signal that contains the sum and difference frequencies of the original inputs. This process is known as frequency mixing. Then operations of mixer. There are two operations. One is frequency up conversion. Second one is frequency down conversion. Frequency up conversion. In the transmitter section of the RF transceiver, the mixer is used to up convert the baseband signal to a higher RF frequency for suitable transmission. This process involves combining the baseband signal with the carrier frequency. It is usually generated by an oscillator. The output of the mixer will contain both the sum and difference frequencies of the input signals. Then frequency down conversion. In the receiver section of the RF transceiver, the mixer is used to down convert the received RF signal to a lower intermediate frequency or directly to the baseband. This process involves combining the received RF signal with a local oscillator signal, creating an output signal that contains the difference frequency which corresponds to the original baseband signal. Let us see the concept of mixer. A mixer is capable of taking two frequencies at its input and producing multiple frequency components at the output. A linear system cannot achieve this kind of task, so we need to select a non-linear device such as diode, BJT or FET that can generate multiple harmonics. The figure shows the basic system arrangement of mixer connected to an RF signal and local oscillator signal, which is also known as pump signal. The RF signal is combined with local oscillator signal and supplied to a semiconductor device with a nonlinear transfer characteristics at its output side, driving a current into a load. After solving and neglecting some higher order frequencies, we will get the current equation I equal to B VRF into V LO cos of omega RF plus omega LO of t plus cos omega RF minus omega LO of t. In this equation, VRF is the magnitude of radio signal, VLO is magnitude of local oscillator signal. V in, that is RF input signal, that is combination of VRF and VLO. V out is the output of signal. Then omega RF, it is a frequency component of RF signal. Omega LO, that is frequency component of local oscillator signal. B is the device dependent factor. In this equation, we are getting two components. One is sum of frequency and another one is difference of frequencies. Then we'll see the characteristics of mixer. One is frequency conversion range. This refers to the range of input and output frequencies that the mixer can handle. Second one, conversion gain. The conversion gain of a mixer indicates the level of amplification or attenuation applied to the input signals during the mixing process. Next, isolation. Isolation is a measure of how well the input and output ports of a mixer are isolated from each other. Next, noise figure. The noise figure of a mixer indicates how much additional noise the mixer contributes to the signal. A low noise figure is desirable for maintaining signal quality and sensitivity in the receiver. Then linearity. Linearity refers to how well the mixer maintains the relationship between the input and output signals. A high linearity is essential for avoiding signal distortion and intermodulation products. Then conversion loss. Conversion loss measures the loss of signal power during the mixing process. It is the difference between the input power and the output power of a mixer. Next, port impedances. The mixer's input and output port should match the characteristics impedance of the connected device or transmission lines to minimize signal reflections and losses. The last one, intermodulation performance. Intermodulation occurs when multiple signals mix together in the mixer, generating undecided frequencies. A good mixer should have low intermodulation distortion to minimize these unwanted products. The circuit design of RF mixer is shown in figure. The RF and local oscillator signals are supplied to the input of properly biased transistor or diode. These are the active device of a mixer. Matching networks are used at input and output side of a mixer to avoid the differences in the frequencies. And to minimize the interference at the output side of the device, it is important to short circuit the input to IF and conversely short circuit the output to RF. The figure shows some types of single-ended mixers. In first figure, the active device is diode, and in second figure, the active device is FET. When compared to BJT mixer, and FET mixer has more advantages like increased conversion gain and isolation between local oscillator signal and RF signal. Next, types of mixer. There are two types of mixers are presented here. One is single balanced mixer and another one is double balanced mixer. Let us see single balanced mixer. The design involving two MESFETs and 90 degree and 180 degree hybrid couplers shown in figure. The 180 degree phase shift is needed since the second MESFET cannot easily be reversed. It is also important to point out this circuit exhibits local oscillator and RF as well as local oscillator to IF signal isolation, but no RF to IF signal isolation. For this reason only, a low pass filter is incorporated into the matching networks of the transistor. Let us see double balanced mixer. The double balanced mixer can be constructed by using 4 diodes arranged in a rectifier configuration. The diode provides better isolation and an improved suppression of spurious modes. Unlike the single balanced approach, the double balanced design eliminates all even harmonics of both local oscillator and RF signals. In this double balanced design, all 3 signal paths are decoupled and the input and output transforms enable a symmetric mixing with the local oscillator signal. Thank you.